Okay, good. So we want to take a look at the solutions to the questions that we have in terms of the the values. Sorry, the that was given for our the solutions that were for the questions that was given for this assignment. So we start with the first one, and the first one asks us to write a program that asks a user to enter three numbers. And I name this numbers.c. Okay. And the program outputs the largest number, the smallest number, and if any or all numbers are the same. So how are we going to approach this? Anybody want to kind of talk me through what was your approach? Anybody
Yes,
want to
sir.
talk me through their approach?
Yeah, Aaron.
Mm-hmm.
All right, so first thing I did was prompt the user to enter three numbers.
Mm-hmm.
Um, okay, my
So yeah,
variables.
we accept three numbers. Okay. You don't have to go through the variables and all of that. We will just talk me through the process, just like as a narrative.
All right, okay. So after you accept the three numbers and you scan, um, then I would have my if statement.
Uh-huh.
So my if statement, it says if
Uh-huh.
number one is greater than number two and number one is greater than number three,
Uh-huh.
or number one is equal to number two and number one is greater to number three, the maximum is number one.
All right. So if number one is bigger than two, and what? And number one
And
is
number
bigger
one
than
is
number
greater than
three.
three.
Okay. So we say
Or
print number one. Uh-huh.
I also had
Or
cases,
in the same line here.
yeah.
Uh-huh.
And I said if number one was equal to number two and number one was greater than number three,
All right.
also print number one.
So N1 is greater than N2. Sorry, not greater than. If N1 is equal to N2 and N1 is bigger than num3.
Yes, sir.
Mm-hmm.
Max is equal to number one.
Is this in the same line as this, or this was something underneath?
It's in the same line.
Okay. And then what? What else?
And or number one is equal to number three
Mm-hmm.
and number one is greater than number two.
Okay. All right. So you find the scenarios where number one is bigger, but then how do you now reconcile printing out that these two numbers are the same?
Yes, I also counted like if they entered if number one and number two are the same number, that
Mm-hmm.
was the if number one is equal to number two and number one is equal to number three.
That's somewhere lower down.
This is an equals minus.
No, yeah, but then how did you get your program to say that those two numbers were the same?
Um, to see them the same. Well, I didn't know that, sir. What I had was if all were equal, then I'd print that. But I didn't have
Right,
any print statement for if any two numbers were the same.
right, but that's what we ask here. If any or all of these numbers are the same. Follow?
Yes, sir.
Mm-hmm. All right. So how then did we get if two numbers are the same or if three numbers are the same? And again, this is why sometimes I think about or I stress, which is it's a good attempt there, Porter, right? Because you got 2 out of the 3 things that were required. But again, it goes back to our problem-solving approach where we must understand the whole question to be able to come up with a solution. So my suggestion here might have been to approach it from this perspective. Okay, 1. So the first thing is to get the 3 numbers. And before I check with these 3 numbers to see if any are the biggest or if anything is the biggest or whatever, and what is the smallest, I would go and I would check to see if the first thing first, I would check to see if N1 is equal to N2 and N2 is equal to N3. And if this is true, then this means that all numbers are the same. Correct?
Yes, sir.
Yes.
And so I could get this out of the way from the beginning. But once all numbers, if all numbers are the same, then the next thing that I would do is check to see if any 2 numbers are the same. So I could go if N1 is equal to N2, then I could print, right? I'm not putting the word print, I could just say N1 and N2 are the same, right? Mm-hmm.
I have a question, sir.
Yes.
So if 2 numbers are the same, right? You're just supposed to print out 2 numbers are the same, or you're supposed to print
Yeah.
out.
You can print out 2 numbers are the same, which is why I'm going to modify this, right? And say and N1 is unequal to N1 is unequal to N3, right? Or N1 is equal to N3 and N1 is equal to N3 and N1 is unequal to N2. Okay? And then you check the last one with being or N1 is, sorry, not N1, N2 is equal to N3 and N2 is unequal to N1. You can modify it and just say 2 numbers are the same. Okay, so we get an instance here where 2 numbers are the same. Okay? And I would suggest getting this aspect of it out of the way first. Yeah? So that you're not kind of constrained when you have to now check the sizes of the numbers. By now thinking in the back of your head, well, 3 numbers are the same, 2 numbers are the same, whatever. Y'all follow where I'm coming from?
Yes, sir.
Right? Anybody took an approach similar to this? Where
I
you
did, sir.
who's
What,
I?
sir? Real, sir.
Oh yeah. Mm-hmm.
Sir, I have a question, sir.
Mm-hmm.
For your second if statement, sir, do
Mm-hmm.
you have to, you say N1, if N1 is equal to N2 and N1 is not equal to N3, sir. Sir, do you have to put that N1 is not equal to N3, sir?
Well, for this line, with it following, if it is that it is,
So, yes,
if
sir.
it
If you
is,
put that inside the first if statement, sir.
okay, no, I was going to say, if it is that you did this if statement here, and then this is an else if, then you don't need to put this here,
Okay,
right?
sir, I was wondering.
because you've already established that they're not equal to each other. You know? But I still like to do it for the sake of completeness. All right. So
Yes, sir.
it depends on how you express your logic. You see how like I have a standalone if here, and this would have been like an end if here. And then we start off with this if here. If it is that I didn't have this as an else if, then yes, it's very possible that I would have gotten I could have gotten the words all numbers are the same printing out and then two numbers are the same printing out. And I don't want that. I want either all numbers are the same printing out or two numbers are the same printing out. Follow me?
Yes, sir.
All right. All right. And then later on we can go into the check-in to see, larger values. Okay, and again, with the possibility of two numbers being the same, you have to, when you check in for the larger values, it would be something like this. It would be like if what? If n1 is greater than n2 and n1 is greater than n3, or you have a situation where n1 is greater than n3, so n2, and n1 is equal to n3, or you have a situation where n1 is greater than n3 and n1 is equal to n2. Then what does this mean? It means that n1 is the largest number in this instance. You follow me? Because you still have to kind of take into consideration, okay, where I had n1, n2, and n3. We have 6, 6, and 5. Right? We could print n1 is largest. Okay? And in this instance, when you print out n1 is largest, you're printing out that 6 is the largest, or something so. Right? Or you could go into more specialized if statements where now you have some sort of structure where you're thinking about, well, okay, if it is that we take a look at n1 being bigger than n2 and n3, right? If it is that you establish that n1 is, for one of these cases, that n1 is equal to another number, or if two numbers matching, that number is either the smallest or the largest, and you can print out the smallest or the largest. That's where you go in terms of your thinking. Okay? Which approach did some of you take with that? Let me hear you all talk it out. How did you get the largest to print out? How did you get the smallest to print out?
So personally, what I did was, zooming on this thing here, say. Right. Basically the same thing, say. But I just compared like num1 and num2 and num3 and num1, stuff like that also. So first I did if num1 is greater than num2, right? Then I put in the largest is equal to num1, right? And then I say else if num3 is greater than num1. Then I put, see, this is the wrong code. What are you going on here? See, this is the wrong code.
Don't tell me that you sent me the incorrect code,
Okay, so let me go with the smallest because the smallest is correct here. So I have put smallest num1 is less than num2 and num1 is less than num3, well, it would be the opposite in this case. So it's num1 is greater than num2 and
Right.
num1 is greater than num3. And
Right.
then with the smallest is equal to num1. Then I have else if num2 is greater than num1 and num2 is greater than num3. Put that in the value of the smallest. And after all those if else statements, I have print f and then I print out the smallest number one time.
Smallest and the largest. So you put them into a variable and then just simply print it out at the end.
Yes, sir. So you would have all
What-
those print statements. Yes, sir.
Yeah, that's fair, that's understandable.
Yes.
Right? Anybody else? But this logic that we have here, and pretty much it sounds like you followed a very similar approach, is all you have to do now to find the smallest is to swap the greater than for less than signs. All right? So it's again, the approach is and this is what I try to see. Go for getting I identify essentially the one impacts the other. Okay, so I would say get finding out if the numbers are the same out of the way first. And then you could go into finding out which one is largest, which one is smallest, etc. And it's just this exercise was essentially 8 if statements. If you could have these 2 if statements at the beginning here, 2 more if statements here that, well, this one favored, this if statement favored N1. So 2 more, one that favors N2 and one that favors N3. And then you just flip the signs on what you did for N1, N2, N3. Okay? So let's see if we could if we could write it up quickly. Right, following the same logic. Anybody absolutely lost or don't know where we at, or find that what we have here is not looking anything at all like what you had and you want to ask about what you had? Anybody? No? So everybody was along the same route? Are they quiet now?
Yes, sir.
No, mine was different. Like kinda, like similar but different.
Okay. So what was similar but different about them, Omar?
Well, oh God. Well, firstly, I did my getting the equal and stuff to the end, right?
Uh-huh.
And I use what I use. I use ORs for like if 2 equal. I use ORs for that. I can send it, just to make life simple.
I will see it. I will see it.
Yeah.
Okay.
Honestly, I can't remember exactly what I have, but it wasn't exactly like how yours is. Mine different. A little,
Right.
not too much, just enough.
Just enough to be distinct.
Yeah, why not? Yeah, that makes it sound nice.
So I could know that who copied from you and nobody. I could say nobody copied from you and you didn't copy from anybody.
Nah, I doubt. I did that like some hour in the night, in the morning. So I doubt.
All
See,
right.
I walk into Oma's house and take a code, so I don't know how you can say that to confidence.
Now I see. Yeah, I know that somebody real sneaky, Oma not even saying that his house has to have good security or something so to prevent that.
Well, I can't say not. I mean, I can't tell him nothing.
No, it's true.
All I know, I do this code. It work. I get happy. I make fried chicken. That was my process, right? That was my process.
I hear you, I hear you. All right, so we have the all numbers at equal part, and for the code that all numbers or two numbers are the same, we just want to know that two numbers are the same, right? We end up with if, and we say if what? N1 is equal to N2. Notice that I don't have an else here, and this is why real, I have to put in my case, I have to put in my case the N1 is unequal to N3. If it is that I had the or, I could have left it out because now I could know that two numbers for sure, at least one number is not equal in this instance. Okay? And maybe we could check it out and see in a little bit. Let's write up the code and see, right? So it's N1 is equal to N2, N1 is equal to N3, and N1 is unequal to N2, right? Or N2 is equal to N3, and N2 is unequal to N1. Right. Okay. So we print in this instance, printf, two numbers are equal. Okay. So let's just test this out as it is right here. Compile. Do I have any errors? No errors as it goes. Enter three numbers. Enter three numbers separated by commas. 2, 2, 2. Okay. So we have 2, 2, 2, 2 here. And we say all numbers are equal. Now we say enter 2, 3, 2. Two numbers are equal. Let's shift and see. Let's shift and see what we wanted to do with how Real would have done it with the else if. Real, you said you did not put any.
No, sir, I didn't put any.
Okay.
Not equal to. So.
All right, so we just comment out the not equal to's. But you had else if.
Yes, I had the else if.
Okay. All right. So let's see, enter three numbers, 7, 1, 7. Two numbers that are equal. Okay. So these are the two different ways that we could have done this. 1, 2, 4. Right? We don't get anything. Okay. So maybe you could have put even down here else.
Yes, sir, because none of the numbers are the same. So.
Right. Yeah. All numbers are listed. Okay. So either way would have worked. That's fine. And now when we get into seeing which number is the biggest and which number is the smallest, we have this piece of code here. Right? But again, we have to we take into consideration, or at least the way I did it, I take into consideration where numbers are equal and bigger or equal and smaller. Okay? So I'm just gonna do the first one, if what? If what did I have here? If N1 is larger than N2 and N1 is larger than N3, or N1 is larger than N2 and N1 is equal to N3, or N1 is larger than N3 and N1 is equal to N2. What does this mean for us? It means printf sign D is the largest. And because you can print out N1 and N1 being equal to N2 or N3 at that time, sorry, semicolon, you will get that if I have 7, 4, 2, all numbers are distinct, 7 is the largest. And now it just becomes a matter of, I would say, copy and paste and change around N1 and N2. So if N2 is bigger than N1 and N2 is bigger than N3 and N2 is bigger than N1 and N2 is equal to N3, or N2 is bigger than N3 and N2 is equal to N1. Okay? So we change it around here, and again for 3, we say, hold a second, please. Apologies. My sinuses are acting up this morning. All right, so we have N3 is larger than N2, and N3 is larger than N1. N3 is larger than N2, and well, N1 is equal to N3 is the same. And N3 is larger than N1, and N3 is equal to N2. So hopefully I have everything correct here logically. Hopefully I have everything correct logically. And let's check it out. Okay, so we have 1, 8, 3. Oops, I have 1 is the largest because I forgot to print out N2 in this instance and N3 in this instance. Okay, so let's check it out again. 1, 8, 3. All numbers are distinct. 8 is the largest. I kind of closed off. Why is stuff just misbehaving? Right. 1, 8, 3. All numbers are distinct. 8 is the largest. Mr. Valles, maybe you should put a printf \n here to go on a new line. And essentially, we could do the same thing, except you have to just change all the greater than signs to less than signs here. Which I hope that when you all did this, anybody realized that once you figured out for the largest, you could just copy and switch the sign and it should be smallest. Yes or no?
Yes, sir.
Yeah, I did that. I wasn't going through that typing again.
Right.
Yeah.
Good. So at least we good there. We covered there. Okay. So if I have 888, right? Oops, sorry, I keep on doing this foolishness where I don't put my commas. 8, 8, 8. All numbers are equal. And nothing else could print because, nothing else is really true. Right? We have 8, 1, 8. We have 8 is the largest. We have 8 is the largest printing out twice because of the fact that I have them in distinct if statements and not really in any sort of else if structure. Okay, so again, I could probably put an else if here and then else here. And I could probably do the same for this. Else if here, return else here, and let's see if that prevents the double print problem. Okay, 9, 1, 1. Two numbers are equal. 9 is the largest, 1 is the smallest. So now I've fixed the problem where you get a double print if you have 2 smaller values or 2 larger values. Was that so bad? no. I was expecting to hear, no, sir. It wasn't so bad. We were beaten up for nothing.
I mean, after all that time I spent, I not gonna say that was not bad. I spent too much time for it to come now and say, act like, oh yeah, that was easy. Nah.
All right. I can't fault Uma. Uma keep it anyway. All right. So we did the numbers one here. It really wasn't so bad. Next up, the second one was, right, we want to enter a sequence of numbers. Entry for numbers is terminated only when the number 0 is entered. The program should output the highest number, the lowest number, the average of all numbers, and the sum of all numbers. Number 2 was essentially something we've done before, not so?
Yes, sir.
Yes, sir.
So you're
Because
practically.
it was the camp question, sir. Well, I think it was the same thing.
Yeah. Sorry. So I don't really have to go through this one then.
Not really, sir.
That's it, normal.
All right. So don't worry about going through this one. Let me hear if anybody wants to go through, you could put up your hand. Okay, we have people who want to go through the question, so I have to go through the question. Okay. So I'll name it seq.c sequence OPER. So sequence operations.c. Okay, we have where we want to enter a sequence of numbers, and we want to stop the sequence when the number 0 is entered. Okay, and we want to mark the highest number, the lowest number, the average, and the sum. So we know that to be able to get the average, we have to keep a count of all the numbers entered. And actually, this is a good example. I'm glad I'm going through this because I want to introduce a concept to you guys called typecasting. Okay, it sounds mystical and magical, and it is like magic when you're programming, right? So we're doing a little bit of magic here. All right. So I'm introducing you all to some of the dark arts of programming. Turn 0. So we want to, let's say we have int, and we have int for the num, which is the number that we'll be entering. We have high. We have low. We have count, and count always starts off at 0, and we have sum, which also starts off at 0. Everybody is fine with these variables. You all understand the purpose of these variables? Yes? No?
Yes, sir.
All right. All right, good. So we want to say, essentially, enter numbers until we hit the number 0. So we can use a do while loop. We could say do what? Do while num is unequal to 0. What we are saying here is do what we want to do as long as the number entered is unequal to 0. So we could say printf enter a number and store that number inside of scanf, inside of num. Scanf %b ampersand num. Once we put a scanf, we have to put a get char. The get char cleans the input for the scanf. Okay? Now we know that we want to do our operations as long as the value inside of num is not 0. So we can say, if what? If num is unequal to 0. And doing this, especially to protect the lowest number entered, because we could enter numbers below 0, but what if all the numbers entered were not 0? If all the numbers entered were not were higher than 0, then when we enter 0 to stop num, and we didn't have this safeguard here, then the lowest number could possibly be saved as 0. Okay?
That makes sense. That makes sense.
Right. So, this is just to say we could put it around the part with just the lowest number, or we could, it wouldn't affect it might affect the average if you actually protect in your count as well, right? So you don't want that 0 pulling down your average as well. So, it's better, we could do everything inside of there. So as long as num is not equal to 0, we check to see if this is the first number. If this is the first ever number entered, then this is the highest and the lowest number. How do we know if this is the first number? Well, if count is equal to 0. If count is equal to 0 at this point, what do we want to do? We want to say high is equal to low is equal to none. So store the number as the highest and lowest number. If it is not 0, which means that we've taken in other numbers, which means that we've established a high and established a low, we have to check. We have to say if num is bigger than high, then high is equal to num. We store num inside of high as the highest number. Okay? And again, for the same thing for the lowest number. If num is lower than low, then we say low is equal to num. All right, so we've already recorded the highest number and the lowest number right here. So we want to get the average of all the numbers entered. So the average of all the numbers entered would be, the average of all the numbers entered would of course be dependent on the count of the numbers. So at this point you could say count plus plus, and you could also add num to sum. So you could say sum is equal to sum plus num. Or if you like your shorthand, you could say sum, right, plus equal to num, if you was interested in the shorthand version of this. These two statements are the same. One is just shorter than the other. Okay? And then you're printing out the sum, the average. So good. So I think we have everything we need at this point to start to print out. So now we could just simply printf, and we'll have probably multiple printf statements. The highest number is %d, and this will be high. Oops. The lowest number is %d, and this would be low. What else do we want to do? We wanted to print out the sum of the numbers. The sum of the numbers are, the sum of the numbers are %, or is %d. This is going to be sum. And this last one is the average of the numbers is, and this one is where we can have a problem. Because if I put %d here and I say sum divided by count, what is going to happen? Is that chances are this is going to be a floating point number, not so? Yes? No?
Awesome.
Right. So let's run it and see what happens at this point. I'm missing right. Let's run it and see what happens at this point. Enter a number. 7, 4, 9, 2, minus 5, 12, 19, 22, minus 8, and 0. The highest number is 22. The lowest number is -8. The sum of the numbers is 62. The average of the numbers is 6. Right? But I mean, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. 62 divided by 9 is not just 6. So how could we fix this? Even if we print out a floating point number here, %f, what happens is that, right, we have, let's say, 5, 5, 5, 5, 5, 5, 0. We don't even get a value printing out because you're trying to store the result of an integer operation inside of a floating point variable. So what we can do is that we can perform, and let me put some \ns here so that each one of these will come out on its own line. We can perform what is called a typecast, which means for this operation, I am temporarily turning this value into another data type. So I have float for the sum in brackets. And what I'm doing is I'm typecasting these values to float. I'm saying take this integer value and treat it as a float for this operation. Take this count value and treat it as a float for this operation. So that when I say, okay, take this sum that we're treating as a float and take this count that we're treating as a float, it should return a floating point value. Let's see if that works for us. It would be terribly embarrassing if it doesn't. All right, 1, 2, 3, 4, 5, 6, 7, 8, 7. All right, 9, 0. So look at what happened here. The highest number is 7. The lowest number is 5. The sum of all the numbers is 47. The average of the numbers is now a floating point value. Because we took these integer values and we said for this operation, treat it as a floating point value. I'm sure everybody's sitting by their desk and like, ooh, we didn't know that. Right? Thank you, Clement. That's all I want. I just want
so
to
that
see
makes real sense. So.
Okay, yes, but it's not something that I would have told you before, so I'm not looking for data, but I would have been looking for whether or not you took in a floating point value as the number itself. Okay, so I'm not looking for this, and I would give you the mark if it is that you had it as an integer and expressed it just as an integer, because I never taught you this as yet. But now you know it, right? I would have expected that you would have said, oh, I should enter my values as a float. Did you do that? Did you all do that?
So I just put sum as a float. So.
You put sum as a float. Okay, and it worked? Did it work?
No,
Yes,
sir.
sir.
Huh? Yes?
Yes, sir.
Clement, it worked for you?
No, sir. I had some as a float, say. Same thing going on, sir. I say, what is this, sir? And now I realize that I should have probably put those other things as floats, you know?
Yeah. All right. Well, yeah. Okay. So yeah, some should have been a float at the very least, because I think that a float divided by an integer will return a floating point value. If it is that the data type that you're returning it to is a float, or if you would have had a float placeholder. So could it be that you did not put the float placeholder, Clement?
See, I'll put %sign F.
And you still only got a 0.0 value coming out?
Yes, sir. Well, it had only decimal places and stuff, and it just didn't have. But I'm gonna double check here and see what exactly I had said.
Okay. All right. So this one was not too bad. Okay. And again, it's something that we would have done before. And the last question is our friend right here that, you know, I gave you all basically the an answer to yesterday afternoon. So we'll name this one stars stars dot C. Okay. And so we have a C program. We want to write a C program that outputs the following pattern. But we get two different patterns based upon whether or not it is a odd number or an even number. So you notice that we have our amount of lines defined. We have 1, 2, 3, 4, 5 lines defined in the case here, and in this one we have 1, 2, 3, 4, 5, 6, 7, 8. And the pattern really indicated we go up to half of the number, and then we come down from half of the number. In the event of an odd, we go up to integer half, print integer half plus 1, and then we come down from integer half. That's the pattern. Anybody looked at it and said, hey, that was the pattern? Right, so I see Clement. Anybody else?
Sir, I didn't look at it like that, sir.
How did you look at it, Real?
Sir, I said we're going up by half, and then we're coming down by half minus 1, sir.
You're coming down. For the, as for the odd?
So, well, I did it for both of them, and it worked.
You're going up to half, because you have 8 and you went up to half, and then you come down by half minus 1. Minus 1.
So that will give them one less stand for each one.
Well, that's what I'm thinking.
Yeah.
Remember, it's only in the instance of this one that you kind of have that extra 1. So for this one, I could think that you could add 1 to the odd, go up to half, and then come down from half minus 1. That would make sense for the odd real. But for the even, it's half and half. So that's what you did for the odd.
So I don't know if I was explaining it right, sir, but I got the right thing at least, sir.
Okay, so I think maybe for the odd number, you carried it up by 1, go to half, and then come down from half minus 1. Is that it? That's the only way I see the half minus 1 coming into play. Right? Real now with his alternative method come and throw off my train of thought. That's all right, Real. Okay, let's see. This one isn't going to be too hard to this one isn't going to be too hard to code up. Okay. So the first things first is that we need a number. We know that we need the number. So we have int num and we have half. Okay. We have int num and half. And then the first thing that we do is that we say printf enter a number. So we enter this number, we store it in scanf, store it inside of %d, ampersand num, and we can say that half is equal to num divided by 2. So I'm going according to the pseudocode that I would have sent you guys yesterday. Let me see if I can find that pseudocode. And this is what I would have sent you all yesterday. Okay, so essentially, I've entered the number, I've input that number, and I said half divided by 2. And what I did is that I did 3 things. I said, okay, if it is that you have an even number, you go up to the half, you skip over this, and you go down from the half to 1. If it's an odd number, like in the case of an odd number, there's an extra step. For the odd number, you would just print one that goes up to half plus 1. So the integer half of 5 is 2. So you went up to 2, you carry 1 up to 2 plus 1, where this is an odd number, and you go down from 2. Right? So that's the difference. What some of you all did was that you all made this distinction here. So you all chose where you have, or you had a second variable for like half plus 1 or something, so half plus, and you worked out and said, okay, if it is odd number or even number, you store 2 different values in half and half plus. Okay, either one is fine once you get the output and once you utilize asterisks. All right, I don't want to see anybody's solution with a bunch of printf statements. Print 1 asterisk, print 2 asterisk, print 3 asterisk, print 4 asterisk. That's not the solution. Okay, because this is dynamic. It has to change according to the number entered.
Really, sir?
You'd be surprised, you know. Right?
So it can't be shaming man code, so you know. If I do that now and I'm proud of it, it can't be shaming me, so you know, sir.
You will be shamed. You will be shamed.
If my code work, you know, like it can't discriminate. It can't be racist towards my code, sir.
That's the kind of code that does explode spaceships. Right? And you watch a spaceship go up in the air and then it blow up and everybody on board die and you're like, oops. I mean,
scenario. Accidents happen, sir. Accidents happen.
We can't have, you know, power plants blowing up and stuff like that, and you as a programmer is like, well, you know, maybe they shouldn't have run it in this particular way. You as a programmer, you have to think about every scenario. All right.
In my opinion, as a programmer, I can simply say, do press that, and if they press it, who's to say I didn't tell them?
That sounds like some iPhone thinking. You know when the iPhone came out and people was having problems and Steve Jobs say, well, are you holding the phone wrong? That's you can't do that.
Exactly. So if you hold the phone wrong, you can expect to make a call.
Exactly. So I agree with Omar, sir. Like if I tell them to only do 5 and 8, they could only do 5 and 8.
Exactly. You know, I just saying for the record, my code working perfectly. Any number entered working.
Well, yeah, same here, but
I'm selling demos. That's what they're doing.
Life essay, what that one say?
All right, let's go. So we say for I is equal to 0. Right? For I is equal to 0, I is less than half. Less than half? Yes. I plus plus, what do we want to do? We want to printf. We want to printf an asterisk, right? Sorry. My bad. I start off bad. I have I and I have J. So we want num amount of lines. So we have to go for I is equal to 0. I is less than num. I plus plus. And what this would do is this would print out the amount of lines that we need. So we say printf asterisk. And what this does is that if I print this as it is, right, asterisk backslash n, I'm going to get, if I have 5, I get 5 lines printed out. 1, 2, 3, 4, 5. But for each one of these lines, I want a certain amount of asterisks on them. Correct? Yes? No? Yes? No?
Yes, sir.
Right, so we have a certain amount of asterisks printed out on each line. That's right. So now we want to now see what we want on each line, okay? And I think maybe I left that out on this. All right, I left out that overarching for statement that will allow me to print stuff on lines. But let's see what happens now. Okay, so right. Oh no, I didn't leave it out. Look at here. Right? But we have to go to for one is I is equal to 0. I is less than, we're not going to num, sorry, we're going to half. So look at this instance now. If it is that I have half and I say, okay, we enter 5. Sorry. Half is equal to num plus 2. All right, sorry. I lost my train of thought here. I should not have taken off this asterisk now. Okay, so we have this printf statement here. And again, in the case of 8, I get 4 asterisks printing out. I go to half, right? If I go to half, and this is where I got my solution. This is how I came up with my solution. So 8, I go to half. So if I copy this here, I go down here and I copy this down here, I'll get half and half. So I could have one half where I could indicate that my asterisk will go up, and then I'll have another half where I could go down. Do you understand where I'm coming from with this?
Understood, sir.
Yes, sir.
Right? So I split it into half and half. But the problem is when I have an odd number, I have up to the integer half and down from the integer half. I have up to the integer half and down from the integer half when I split half and half. So that's why I eventually put in this line here that says, okay, for the integer half, go up to half plus 1. All right, so, and bear with me, okay, bear with me. Now I want to say, okay, for each half, I want to go up to for j is equal to 1, semicolon. J is less than, so j is equal to 0, sorry. J is less than or equal to the value of, j is equal to, less than or equal to the value of I, right? Semicolon. J plus plus. Now I want to print an asterisk. Print an asterisk. So on each line, I print a certain amount of asterisks. How many asterisks? Well, according to the line number here, indicated here. Okay? So, and after each line is finished, I have to go down to the next line. So as it is right now, if I run this and I say 8, why do I have 2 coming up here? Oh, sorry. I put 1 instead of I. If I put the number 8, I have the first line, my asterisk only prints up to 1. The second line, my asterisk only prints up to 2. The third line, it prints up to 3. The fourth line, it prints up to 4. Because this is moving from 1 to 4, because 4 in this instance is half. So that's how I get the climb up. Make sense? What about, right. So what about if I want to go down now? So for going down, I should start at half and go down to the value of, right, greater than 0. So I should go down from 4 to 1 essentially. And I have to send it downward, so I say I minus minus. Okay, and I do the same thing inside of here. I say for what? For j is equal to, for j is equal to 0, j is less than or equal to the value of I, j plus plus. So in this instance, I am printing, we started at the value of 4, then when it goes, it will go to 3, then 2, then 1. And that is how I get the down part going. Okay, the down part is going like this. And again, I need to put a printf \n here. Okay, so we have build and run, we have the 8. I put the \n in, I have to take this \n off of here, sorry. So we have 8, and that is how we get the value there, right? Why do I have an extra asterisk printing somewhere? 1, 2, 3, 4.
So maybe you could put the printf statement right below the, well, the new line statement right below the printf statement with the asterisks. And this when you're coming back down, and see if that would help.
The new line statement.
Like inside of the loop above it.
This loop?
Yeah, like.
No,
yes.
that would print out the asterisk and printf on each line. I did something foolish here. J is equal to, sorry. J is equal to not 0 in this instance. J is equal to 0. J is less than or equal to I. So J is equal to 1. J is less than I. Let me just try that there and see. Oh, hey, I'll find a different way to print 1, 2, 3, 4, 5, 6, 7. Wow, look at that. All right. So I is equal to half. Let me just think it through. I've messed myself up here for a second. This happens from time to time. Okay, so I is equal to half, and of course half in this instance is 4. Half goes down to 0, right? So for j is equal to 0, j is less than I, j plus plus. Okay, so j should start off at 0. Print 1 asterisk for 0, 1 for 1, 1 for 2, 1 for 3. And then print a \n. This should work. Mr. Valdez, what is going on with you? Yes. Okay, so I got it to work as I intended now. All right, so my bad. I apologize for the little throw off, right? I don't know what funky code I had there before. I think I had a 1 here or something. So, but we start for the second half, as I said, and this is for the evens we're working with. For the second half, we start at half, and then we go down to half minus 1, half minus 2, half minus 3. Okay? So it's an exact mirror of the top half, where we started at 1 asterisk and we're moving up towards half. Okay, we started at 1 asterisk and we're moving up towards half. Now we're starting at half and we're moving down towards 0. But what about the instance where an odd number is entered? When an odd number is entered, 9, we get the same pattern as when an even number is entered. And what that means, what should have happened is that there should be one line between these two here that would go up to 1 more than this. And so if you look in the pseudocode, that's this instance here. It said if it is the original number is an odd number, then just print a single line going up to half plus 1, right in the middle there. So if it is, I say if it is num mod 2 is equal to 1, what do I want to do? I want to say for, just like this inner for loop here, right? For j is equal to 0, semicolon, j is less than half plus 1, because it needs to go up to 1 more than the integer half of that odd number. Half plus 1, and then you go j plus plus. Then what do? We say printf, and you print your asterisk. And once you have finished printing that, you printf a \n to go on the next line. Okay?
So,
And this,
see, I have a, right, see?
you have a
suggestion, see.
Mm-hmm.
So, instead of printing a whole next loop to one line, see, what you could, if num mod 2 is equal to 1, right? See, you could say half is equal to half plus 1. So you wouldn't have to make all the code.
So
like,
right. So yeah, so this is what Omar would have done. He would have, and this is what I would have alluded to before. You could change the value of half and do, for the first instance, carry it to for an odd number, you could carry it up to that changed half, and for the second half, just print down from your regular. So again, I accept this is not the only way to do this, right? But let me run this, and then we could make that modification. No problem. No probs.
yeah, no problem.
All right. So we have a number like 9, and 9 puts us with our middle value inside of here. So essentially, we go up to the integer half of 9. We run that one with the half plus 1, and then we go down from the integer half of 9. Okay? And this statement in the middle here has no bearing on any even number. It has no bearing on any even number. Okay, so for the even, we still end up going up to the integer half and then down from the integer half, with 16 lines in total here. All right. I want to give you all a break. 5-minute break. So when we come back, it was Clement.
Yes, sir, but it's okay. I don't need to go through it, sir, because I think I already know how it will look, sir.
Well, it should look like the pattern, right? All right, so we're taking a 10-minute break. We're coming back at 10:25, and I want us to talk to you all a bit about some characters and strings, and actually some ASCII values as well. Okay? All right. 10 minutes.